Hey everyone, it's Mr. Morrissey. Today our objective in looking at complex numbers is to perform arithmetic operations with complex numbers, including using the conjugates, which we practiced last lesson, and solve quadratic equations with real coefficients that have complex solutions. Let me point out a few things. Big thank you to one of my students who pointed out that I can have an array of highlighting colors. So here, ooh, that's sort of dark. Well, let's do a different one. Let's see. Let's do yellow. So I erase that. So here, basically it says it talks about the history behind complex numbers. But basically, when we talk about imaginary numbers, we're talking about I, which is the square root of -1. So for example, if you were trying to solve the equation x squared equals -1, if you were to square root both sides, you're going to get x equals plus or minus I. So I, anytime you have the square root of -1, square root of -1 is going to equal I. And we're going to practice this. It seems a little bit out of the ordinary, but I think you're going to see this is really just a case of simplifying square roots that have negatives underneath them. Another thing here, I see complex number written in standard form is a plus bi. So that's going to be important, writing in a plus bi form. And then let's see, in a complex number equation is only going to see if you have here a plus bi and c plus di. If you want to know if two complex numbers are the same, then you have to line up the parts. So if you look, it says complex number, oh, there's the bell. Complex number in standard form a plus bi. The real part is the a, and the imaginary part is the bi. And so you need to line up the imaginary parts and the real number parts. So a has to equal c, and bi has to equal di. I think it might be worth it just to get right to it and just start by doing some problems, and I think this will become more clear. But basically we're dealing with times when you have negative numbers underneath the radical. So let's see. The first one, what is the conjugate of 2 minus I? Well, we've already practiced this with square roots. That's going to be 2 plus I. And 10i is a special case, but if we wanted to, we could write it 0 plus 10i. So the conjugate of 0 plus 10i is 0 minus 10i. So negative 10i is going to be the conjugate of 10i. The next one, find all real numbers a and b that will make 2 minus 6i equal to 2a plus 3bi true. So the real number parts are going to be equal, and the imaginary parts so this is going to be 2 equals 2a, and negative 6i equals 3bi. So I think we can see a is 1, and it looks like b would appear to be negative 2. Let's see if this makes sense. So 2 minus 6i, left-hand side, that equals 2 times a, well that's 2, and then 3 times negative 2, that's minus 6i. That's the right-hand side. And the right-hand side equals the left-hand side. Done. So if you saw back in the first page, it just talked about a little bit about the history, that the complex numbers were made like in Egypt, I believe. And it says Greek mathematician Heron of Alexandria, and later Euler, I should say, created an expanded system of numbers using the imaginary unit I, which was the square root of -1. So it was like a new set of a new number system that was created hundreds of years ago, to deal with taking the square root of a negative number. So we're going to do that right now. Okay, so this example 3 really is the key core thing of our objective. So to solve this equation, to find out what value or values for x, we could plug in square, multiply by 2, add 11, you would get negative 37. So the first thing I'm going to do is subtract 11. Whoa. Oh no, that was right. So negative 48. Sorry guys, you can't really see that. Negative 48. So negative 24. So here, you're going to do just what we did on the square root section last section. You're going to square root both sides. So you're going to get, don't forget the plus or minus, square root of negative 24. Now remember, our little friend, imaginary 1. So imaginary 1, the square root of the square root of negative 1, I meant to say negative 1. The square root of negative 1 is by definition I. So the next thing I would do is write plus or minus I root 24. And then the only thing we left to do is simplify square root 24. But we already practiced that in the last lesson. So let's find the prime factors of 24. That's 2 times 2 times 2 times 3. So here's our answer. X equals plus or minus 2I root 6. I should point out here, even though we're going to come to it in a second, let's make the I chart. I squared is negative 1. I to the third is negative I. And I to the fourth is 1. We're going to get to that in a second. But that will be important. I know on the SATs, if you're asked a question with I or SAT 2s, they always tell you I squared is negative 1. All right, we have a tough problem coming up, number 4. Very hard. So I'm going to have to do this one, be very careful here. A plus BI divided by C minus DI. Write that as a complex number in standard form. Basically, we don't want to have an imaginary number in the denominator. Okay, so we really, this is going to be tough. So I'm going to rewrite the equation, or not this expression. I can't read that. So A plus BI divided by C minus DI. Okay, the conjugate, remember doing conjugates with square roots? It's the same idea. So we're going to multiply by the conjugate. And the conjugate, like we did in example 1, is C plus DI. We're going to be very, very careful here because we can see this looks pretty tough. We're going to FOIL, or I like to call it just expand. Okay? AC, BCI, ADI, plus BDI squared. I'm going to pause for a second. I'm going to double check that foiling in my head. So the first two terms are AC, then I have BCI. Yeah, BCI, there are those. So BCI, then ADI, and then BDI squared. Got it. Looks like I hit those. Take a look at that work, see if you agree. You can always hit pause, remember. Now I'm going to FOIL the bottom. Remember, the bottom here, that's a difference of squares. So the middle terms are going to cancel. Recognizing difference of squares, that structure is one of the most important things I would say, in addition to factoring, that you would come out of Algebra 2 with. So that's C squared minus D squared I squared. Let's do a little simplification. I realize the first time this is overwhelming, but I really wanted to do it in general case with no numbers to really make sure you understand this. So you want a plus bi form. So I'm going to group together in the numerator the parts that don't have an I. Well, this bdi squared, in the last problem we wrote down that I squared equals -1. So I get to rewrite the I squared is -1. So AC minus BD plus, let's see, A plus BI form. So I want BC plus AD I. Pause for a second. Take a look at that numerator. Make sure you understand it. We have AC minus BD plus BC plus AD in parentheses times I. All I did was group together the two terms that had an I on them. Underneath, in the denominator, I squared is -1. So we have CD squared, sorry, we have C squared minus D squared times -1. So one last thing to do. Keep in mind, guys, if you can do it with letters, you can do it with numbers much easier. So this is a good place to begin in the most general form. So if you notice, I have gotten rid of the di. I've gotten rid of the imaginary part in the denominator. I've rationalized the denominator by multiplying by the conjugate. I think this is the most difficult problem on these note sheets, for sure. The answer, AC minus BD plus BC plus AD, that whole thing times I, divided by C squared plus D squared. Oof. Maybe you should take a break, mental break. Oh, you're good? All right, I guess we can keep going. Let's go to 5. So let's see. What is the sum, difference, and product? Okay, here's the arithmetic operations. So sum. For sum, you're just going to add up the real parts and add up the imaginary parts. Well, the I parts cancel. You get 3. Product. We've already done this a few times today. Basically, we're just going to be expanding. So for product, let's just do some foiling real quick and then some simplifying. So 2 times 1 is 2. 2 times -2i is minus 4i plus 2i minus 4i squared. So 2 minus 2i minus 4 times -1. Remember, I squared is -1. That's a key thing to know coming out of this lesson. So 2 minus 2i plus 4. That's the product of 2 plus 2i times 1 minus 2i. The only difference that I see, you were, oh, sorry, whoever tells me the name of who sings that song, the artist, the group, hopefully I'll have those candies and you can win a piece of sugar-free candy. So, difference. I'm going to take the difference between, so there could be 2 answers, but let's just take 2 plus 2i and subtract 1 minus 2i, okay? So if we do that, this honestly, guys, is just testing, do you know how to distribute the negative? So 1 plus 4i. This is in part of the objective that says the arithmetic operations. Here we multiplied, we added, and we product, multiplied, added, subtracted. Okay. Nice job. Okay, here's where we need to really look at the eye chart, okay? So think of your optometrist or your ophthalmologist. That's the one that's the doctor. Um, so I, that's the square root of negative 1. I squared. Okay, I really want to make sure. I'm going to model this as best I can. I'm going to write this as best as I can. So I is the square root of negative 1. I squared is negative 1. I cubed. Well, I cubed, guys, is I squared times I to the first. Well, we just showed I squared is negative 1. So this is negative 1 times I. That's negative I. I to the fourth is I squared times I squared. Well, I squared is negative 1. That equals 1. So this repeats in cycles of 4. So I to the 27th, well, 27 is 2 ticks away from, no, it's 1 tick away from 28, and you know 28 is divisible by 4. So this is really I to the third, and I to the ninth, well, I to the ninth is 1 after I to the eighth. So I to the eighth is equal to I to the fourth, which equals 1. So I to the ninth is 1 after that. Well, that's just going to be I. So that's minus I. So I cubed is negative I. And believe me, we will be practicing this in class because I know this is tough. The answer to this one is negative 2I. All I'm doing is finding out basically what the remainder is when 27 is divided by 4. That goes in 6 times with a remainder of 3. That remainder of 3 represents I to the third. And 9, I to the ninth, right here, 9 divided by 4 is 2. So I to the eighth divides evenly. So I to the ninth is one place away from I to the eighth. So if you wanted to count, watch guys, I don't know if I can make this clear on the iPad. 1, 2, 3, 4, 5, 6, 7, 8. 9 would be right here at I. That's why this was an minus I. Well, thankfully we only have one more question, and then know that your problem set's going to do a ton of practice with I's and solving equations that have imaginary solutions. So the last one, we're just going to be doing a bunch of foiling. So let's do this. Let's leave the 5. Ooh, hold up. Let's move. Okay, let's move 5I, and let's FOIL the inside. Well, the inside, you should notice these two here, that's a difference of squares. So this is going to be 4 minus 4I squared, right? Because 2 times 2 is 4. 2 times 2I is plus 4I. Negative 2 times 2 is minus 4I. And then minus 4I squared. The middle terms cancel, and we're going to get I squared is negative 1. If that's one of the takeaways we get from this lesson, that's going to be enough. 5I, 4 plus 4 is 8, 40, I. Just keep in mind, as a final summarizer, anytime you have an equation, x squared equals negative 100, you square root both sides, you get plus or minus square root negative 100. That's plus or minus 10 square root negative 1. By definition, this expanded set of numbers that just got created, say, 500 years ago, square root of negative 1 equals I. By definition, that's plus or minus 10I. And second thing that's probably most important for our class is knowing that I squared is negative 1. You guys have been great. Have a great day. We will practice a lot in class. Bye.